So we're going to talk about conditional probability today. So do you guys remember from last week the pierced ear example where we were talking about males and females and whether you have pierced ears or not? So this is the same example. It's nothing different. It's the same exact example, okay? But I'm going to ask you some different questions. So here's the first question. If we know that a randomly selected student has a pierced ear, what's the probability that they are male? If we know that they have a pierced ear, what's the probability that they are male? Tell me what fraction you would use to answer this question. 19 over 103 or 19 over 178? Why 103? Okay. Basically, guys, what I'm saying here is if I know that I'm in the pierced ear section and nothing else matters, what's the probability that they're male? So that would be 19 over 103. And that equals? I don't know either. Actually. Nope. Okay, so there it is. Now I know that the probability that if you have a pierced ear, the probability that you're male would be 18.45%. Okay? All right, let's try another one. If we know that a randomly selected student is male, what's the probability that they have a pierced ear?
19 out of 90.
19 out of 90. Very good. 19 out of 90. Again, because I know that they're male, I'm looking at that column only. Nothing else matters. And I want to know the 19 over the 90. Okay? That is 0.211. Last one. If we know that a randomly selected student is female, what's the probability that they do not have their ears pierced? 4 out of 88. Perfect. I'm in the female section. These other things don't matter. And I'm looking at not pierced ear, which is 4 out of 88. And in case you are keeping track, that is 0.045. So if I know that they are female, there is only a 4.5% chance that they do not have a pierced ear. Do you guys have any questions about that? Okay, let's try some more. We have a survey that was taken at a large apartment complex. It reveals that 68% use Facebook, 28% use Instagram, and 25% do both. Suppose we select a random resident. We're going to define F as a Facebook user and I as an Instagram user. Can you guys make the Venn diagram? Do it. Drawing a circle is the hardest part of the Venn diagram process.
Yeah, I gotta do the hardest part.
It hurts my head. I need to calculate. It's just the hardest thing in the world.
Subtraction is the hardest thing ever.
I'm gonna try it.
You can do it. I have faith in you.
I can't do that. What's the outside part?
I think it's gonna be good.
Alrighty. What are you going to label first?
The middle.
The middle. And what is the notation for the middle? F and I. And what is the percent that goes there? 25%. Perfect. All right, I'm going to go to the left of that section. What did you guys label the left of that section? F and I complement. Perfect. And what percent goes there?
43.
Why at 43? Perfect. So this whole circle needs to equal 68, and now it does. All right. What did you label to the right of that middle section? Okay. And what percent is here? Only 3%. That's because 28% use Instagram total, and that whole circle has to equal 28%, and now it does. Is there a section that we have not labeled? What is it? Is they don't use either one. F complement and I complement. These are our Amish people. No, I'm kidding. How much? 29%. Perfect. All right, you guys. Now we have some questions to answer. Given that the person uses Facebook, what's the probability that he or she uses Instagram?
25%.
Given that they use Facebook, what's the probability that they also use Instagram?
25 over 68.
Boom. Here's how this works. Let me show you guys with the numbers. Okay, so look. If the person uses Facebook, so that's this circle right here, right? That means none of this stuff over here matters. If they use Facebook, what's the probability that they also use Instagram? So it's the 25% out of the total of that section that I was restricting it to. That is the 68% that use Facebook. So 25 over 68, and that is 0.3676. Okay, so again, here's what we did. Just like we did with the table on the front page. We're just restricting to the Facebook circle, and then we're saying, okay, out of these 68%, what percent also do this other thing? That's 25 out of that 68, okay? Let's try it again.
Gotcha.
Next problem says...
Wait, what was the decimal?
0.3676. Given that a person uses Instagram, what's the probability they also use Facebook? Okay, what are you thinking?
25 out of 28%.
25 out of 28. Does everyone agree with that? Okay, so given I'm in the Instagram circle, that is 28%, so that goes on the bottom. What is the probability of also Facebook? And that's the 25 in the middle. So 25 out of that total circle of 28. So basically what you are focusing in on goes on the bottom of the fraction, and then the other part goes on the top. All right, last one. Let's try this one. Given that a person does not use Facebook, what's the probability that they do use Instagram?
3 out of 29. Or 3 out of 31. You're not serious. 3 over 31.
Y'all are not adding well.
32.
Yeah. All right. So what are we crossing out here? We're crossing out the Facebook circle. So we're crossing out these people here. And so what is left over is the 32%. And out of those 32%, which ones are using Instagram? Only 3. So 3 out of 32. Where did we get 32? We added up what was left over when we said we are not doing Facebook. So we're not doing Facebook. That's 32%.
But we're also not doing Instagram on that.
On that one, Instagram, well, it's the people that are using Instagram and Facebook have to go away because Facebook's out of the picture.
I know what 29 is not using either.
29 is not using either. So they're not using Facebook. Neither are these people. Yeah. All right, and so 3 out of 32 is 0.094. So what you guys have just experienced is called conditional probability. Conditional probability, okay? So let's define conditional probability. Conditional probability is the probability of an event occurring given another event has been met. probability of an event occurring given that another event has been met. This is conditional probability. And you'll be happy to know there's some really fancy notation that goes with it. You ready for this?
Yes.
There it is. This is the conditional probability of A given B. This is the probability of A given B. If that's how I read that, probability of A given B, if that's how I read that, then which event had to already occur? B. So don't think it's in order from left to right. It's also not in alphabetical order. So B here is the first event, and that is called the condition. So under the condition of this event, we're finding the probability of something else occurring. So A in this situation is the second event. That little line, that vertical line in the middle, when you see that when you're doing probability, it literally means the word given. It's basically just indicating, hey, we have a conditional probability here. So again, don't get caught up on the alphabetical order. Don't get caught up on which one comes first, left to right. If you see this given symbol, that means that the event that comes after it has already happened, so it had to already have occurred. Okay. I have another formula for you. I love formulas. Formulas are great. This one is also on the formula chart that you will have access to from now on forever and ever. Probability of A given B equals the probability of A and B divided by the probability of B. Now, time out before you freak out. You guys have already been doing this.
Okay, good.
You've been doing this today already. Okay? When we were finding the probability of being male, given that you had pierced ears, what did we do? We put the pierced ears on the bottom of the fraction, and we put the males with the pierced ears on the top. So we were already doing that. When we were looking at the Facebook and Instagram problem, we said the probability of Facebook given you did Instagram, well, we put Instagram on the bottom, that's the second event, and we put Facebook and Instagram on the top. And when we did probability of Instagram given Facebook, we put Facebook on the bottom, and we put their overlap on the top. You've already been doing this. This is very intuitive, okay? When you throw in the notation, people freak out and go, I don't know how to do that. Yes, you do. You've already done it. Here's what you need to keep in mind. The conditional event, which is the first event that has to already happen, goes on bottom. The conditional event, the first event, it's the base of your problem. Given this base has occurred, what's this other thing? And so that has to go on the bottom, okay? Does that make sense? Year. All right, cool. We got one example, and then we're done and caught up. Look at you guys being awesome. Let's look at this example real quick. You can do it. You can do it. Students at the University of New Harmony received 10,000 course grades last semester. They received how many course grades? 10,000 total. The two-way table below breaks down these grades by which school in the university taught the course. The schools of liberal arts, engineering and physical sciences, and health and human services. All right, so we've got A's, B's, and then below a B. Okay? A's, B's, and below a B. College grades tend to be lower in the engineering and physical sciences, the EPS, than in the liberal arts and social sciences, which includes health and human services. Choose a University of New Harmony course grade at random. Here are your two events. E is that the grade comes from an EPS course. That is the Engineering and Physical Sciences. So that's E. That's event E, is that it's in that particular EPS, Environmental and Physical Sciences. L is that the grade is lower than a B. Do you guys see where that is? L is going to be here in this column. This is L. I don't know why I did that. All right. We need the probability of L. What am I asking you to find? The probability that a student got a grade below a B. What kind of student? Any student. I am not restricting anything here. So this is the probability of a student getting lower than a B. Well, how many total grades are there? How many total grades are there for all of the students?
200.
It told us in the problem? 10,000. So out of all 10,000 grades, how many were lower than a B?
3,600.
How'd you get that number? You literally just added these three things up and got 3,656, 3,656, and that literally happens to be 0.3656.
Wait, is it?
Okay?
No way.
So what does that mean? That means there is a 36.56% chance of getting lower than a B at this university. So this is everybody. This is at this whole university. There is a 36.56% chance of getting lower than a B. So far, so good?
Yes.
All right. Now, we need to find the probability of what? Somebody read that to me right there. Probability of E given L and probability of L given E. Okay, here we go. The probability of E given L. All we got to do here, guys, is we need to find the probability of E and L's overlap divided by the given or the condition, which is the second event, which is L. So this is not that bad. We're restricting to the column of below a B. So what was the total for below a B? 3,656. That's what's on the bottom of the fraction. That's what we're restricting this to. Given that we have a grade that's below a B, what's the probability that we are also in the engineering and physical science? So now we look at where E and L come together. And how many are those? 800. This is 0.2188. Now we need to find the other one. This is going to be the probability of L given E. That's going to be the probability of their overlap, which is, here's good news, you guys. The top of the fraction is the same. Whether I say E and L is the same as L and E. Doesn't matter. So what goes on the top? The 800. Okay. Now, on the bottom, I need the total for the engineering and physical science. Okay, so all we have to do is add those three numbers up and we get 1,600. Oh my gosh, you guys, you all know this one. What is what is 800 or 1,600 equal as a decimal? 0.5. Okay, here's the final question that was asked in this problem. Which of these helps us to see that students in the EPS tend to earn lower grades than the rest? Which of these probabilities help us to show that the students in the EPS earn lower grades than the others? Yeah, so guys, what is the chance that you're going to get lower than a B in all of the university? That's part A. What was the chance that you would get lower than a B in the whole university? 36%, right? That was part A. This tells us that if you're in the environmental and physical sciences, your chance of getting a B, lower than a B, is now 50%. So that tells us that it's hard being in the environmental and physical sciences, okay? So the probability of L given E shows EPS is hard.